Okay, so today we're going to talk about correlation, causation, and equations of lines. So we will first start off with correlation. You can see in these graphs here we have pictures of positive correlations, negative correlations, and then no correlations. And really all a correlation is like a slope. So you can see in this first graph here that it says a high degree of positive correlation. Look at the data points. Look at how tightly they are clustered. Look at how strong that best fit line is. So a best fit line is really just a line that would go through those points, kind of has an average of all of those slopes. You can see that there's that positive slope. That slope is going up. Whereas this next one, you have a negative best fit line, a negative slope. The data is going, with a negative slope, it's going down. And then this last one here, there's no correlation. There's just a whole bunch of points on the graph. They're all scattered around. They're not in any sort of relationship going up or down. So we call that no correlation. The ones below here, you have a low degree of positive correlation. So you can see that we still would have that best fit line that has that positive slope. However, because the points are more spread apart, we have less of a correlation. The tighter the points are together, the more correlated, the more tightly knit the data is. Whereas here we have a low degree of negative correlation. It's not saying that the slope is any less steep, it's just saying that the points are farther apart from each other. They're less tight knit data. So if we look at this example, we're going to plot the set of values. So we've got all of these ordered pairs here in our XY chart. So I'm going to go ahead and graph these, so you go ahead and do the same. Okay, so go ahead and pause the video a second. Make sure that you're plotting all of these points. You should have 10 total points. Remember how to graph points from the origin, from the center. The X value is going left and right, so if it's negative, you're moving left. If it's positive, it's moving right, and then the Y value is going up or down. So again, negative if you're going down, and positive if you're going up. So you want to move in the X direction first. Remember, ordered pairs are X, Y. So I've graphed my points already. Now we're going to try to figure out what type of correlation is present. So if we go back to our charts that we had with the positive, negative, or no correlation, you're trying to look at this data and decide what kind of correlation, meaning is it positive, is it negative, or is there no correlation. And you can kind of see that there is a positive correlation there. We can kind of draw that line of best fit that's going to have that positive slope. So what type of correlation is present? We're going to go ahead and write positive linear. Positive linear correlation. Now we want to go ahead and say linear there because it's that line, it's that linear shape. There's other types, you won't see it too much, but the I-STEP is going to ask you what type of correlation, and positive linear correlation would be the best possible answer you could have in this situation. Now, identifying any outliers. Outliers are data points that just don't really fit the trend. Okay, this has that positive upward trend. We can kind of see that this point out here, that doesn't really fit the trend. It's kind of doing its own thing. So the outlier, that ordered pair, is 3, negative 4. So it's this guy right here, and identify any outliers. So we're going to go ahead and say 3, negative 4 is the outlier. And then what would happen to the correlation if you removed the outlier? So if we took that outlier out of our data, what's really going to happen is the graph is going to show a stronger positive linear relationship, because right now, although we've got that positive best fit line, this data point out here, that's that outlier, is kind of pulling the data, it's skewing the data a little bit. But if we have that point removed, if it wasn't part of our graph, then we could see that more of our data was closer to that best fit line. That kind of goes back to these examples over here. The closer your data points are to that best fit line, the stronger correlation you have, the higher degree of positive correlation. So what we can say here is the graph would show a stronger, so we want to talk about how that positive correlation is going to be stronger, a stronger positive linear correlation. And we already talked that it was a positive linear correlation, and we could say correlation, you can say relationship, whatever you want to whatever you want to go with. Just be complete with your statement and make sure you're indicating that that relationship is going to be stronger because the data points are going to be pulled closer to that best fit line. Okay, so the last thing we're going to talk about before we talk about equations of lines is the difference between correlation and causation. So if we read our definitions here, correlation says when two sets of data are linked together to show similar data trends, versus causation is a direct cause and effect relationship between two sets of data. So correlation is almost more of a coincidence, where causation is a fact. It's like the more products that you sell, the more revenue that you're going to bring in. So one thing we have to be able to do is differentiate within statements of, is it a correlation relationship or is it a causation relationship? So we'll do a couple of practices here. So A says the more minerals there are in water, the harder the water is. So is that a correlation? Is that just something that, you know, is kind of true, it just happens, it's like a coincidence, or is that a direct cause and effect relationship? Well, that's a fact. The more minerals there are in water, the harder the water is. That's why some people need water softeners at their house, because they have hard water. So this one is going to be a causation. The minerals in the water are causing the water to be hard. So we're going to go ahead and write causation. B says the more you pay for a house, the more you spend on a car. So if you have a house that costs, I don't know, $400,000, so you have a really expensive house there, the more you spend on a car. Is it necessarily true that just because you have an expensive house, then you have to spend a lot of money on a car? Is that directly a direct cause and effect relationship? Or is that just something that, generally speaking, the people that have really expensive houses will have more expensive cars? So you got to really think about that. Is you having a more expensive house causing you to have a more expensive car, or is it just so happened to be true that people with more expensive houses tend to drive more expensive cars? So that's going to be the latter of the two, that people with expensive houses tend to drive more expensive cars. That's just going to be a correlation in the data. C says a fast food restaurant hired 2 new employees and the sales went up. So are those 2 new employees causing the sales to go up? Is that something that because those 2 new employees are now working at the restaurant, the sales have gone up? Or is it just kind of a coincidence that they hired 2 new employees and now the sales are going up? So you have to think about, did those 2 new employees, are they specifically causing the sales went up? Are they the reason why the sales went up? No, they're not. It just so happens to be that they hired some new employees and now their sales have gone up. So maybe they're expanding. Maybe there's other reasons within the business why they hired more employees, thus why their sales are going up. So this one is also going to be correlation. Now the last one says, as deposits in a savings account increase, the interest earned on those deposits increases. So when you think about savings account, the amount of interest that you're earning is based on the amount of money that's in there. We talked about that in our chapter with exponential growth, that if you have 3% interest, well, you're going to earn more interest on $500 than you would on $50. So as deposits in a savings account increase, is the increase in the amount in the savings account, is that causing the interest to also increase? Now, it's not saying the interest rate is increasing, because that's not changing, but the amount of money you're getting is increasing, and that is directly caused by the more money in the savings account. So this one is going to be a causation. Some of them can be a little bit tricky. Just try to rephrase it a couple different ways and see, is the first part actually causing the second part, or is it just kind of a coincidence, just a relationship?